Today's topic is green infrastructure solutions for stormwater management. Our guest speaker today is Dr. Zafar Adeel. Pleasure to have you, sir. I'll start with a brief introduction. Dr. Zafar Adeel serves as the Executive Director of Pacific Water Research Center and as a professor at the School of Resources and Environmental Sciences and Management at Simon Fraser University, Canada. He has over 25 years of experience in a broad range of environmental sciences and policy issues. He served as the Director, United Nations University Institute for Water, Environmental and Health from 2006 to 2016. He has also served in a number of international leadership roles, which includes chairing a group of over 60 organizations called UN Water during 2010 to 2012, and co-chairing the Millennium Ecosystem Assessment Team of scientists that produced the Global Desertification Synthesis in 2005. His research focuses on the intersection of natural resources management, innovations in livelihood, and community-engaged research activities in rural, as well as First Nations communities. So this was just a brief introduction. Before we start, I would like to inform the participants that a recorded version of this webinar will be available. And we will try for this to be an interactive session. In case of any queries or questions, the participants can use the Zoom chat option or the raise hand option in Zoom. So without further ado, sir, over to you, sir.
Well, thank you very much for that kind introduction. Bismillah ar-Rahman ar-Rahim. Assalamu alaikum to everyone. Thank you very much for joining us this morning. And I'm very grateful to NESPAC for giving this opportunity to talk about this interesting topic. And I'll explain what I'm going to do in a minute, but I would like to start with two acknowledgements. The first one is that I live and operate on the unceded and traditional territories of Canadian Indigenous peoples, and these are called the Coast Salish people. The beautiful territory that you see in my virtual backdrop essentially belongs to these First Nations, as we call them here in Canada. And these territories were never ceded to Canadian government. So it's a great privilege to be on these beautiful lands, and we are always acknowledging that they belong to the Indigenous populations. Let me share my screen and I'll go to my second acknowledgement. So the topic is green infrastructure solutions for stormwater management. And I would like to acknowledge a number of graduate students who have helped me with the research behind this presentation and putting together some elements of this presentation. Andrea McDonald is a master's student who graduated earlier this year, and she looked at the regulation and policy frameworks. Nick Mead Fox is a current master's student under my supervision, and he's looking at the engineering standards for green infrastructure. And Ghulam Hassan was a visiting PhD candidate at the time in 2019, and he worked under my supervision here at Simon Fraser University for about a 6-month period back in 2019. So I'm very much grateful for these colleagues for providing inputs towards this presentation. Okay, so what I'm going to do today is, can everyone see my my slides correctly? Umar, are we good?
Yes, yes, we're good.
Okay, wonderful. So what I'll do is I'll just take a couple of minutes to talk about the Pacific Water Research Center, which I lead. And I'll talk about how this center and its research is connected to green infrastructure. And I'll then get into describing green infrastructure and nature-based solutions, how they operate in urban settings. And then I'll go a bit more in depth and talk about various categories and their engineering design. I won't get into the nitty-gritty details of the engineering design, but hopefully it will give you enough of a flavor to understand what the complexities are and what some of the challenges are in their implementation. And then I'll describe some examples of these GIS solutions, including a project on rain gardens that my center had implemented. And I'll summarize some findings and overall evaluation of this work, which will include identification of issues and some of the strategic benefits of these applications. And I'll leave you with some questions, which hopefully will trigger some discussion and debate. And hopefully we'll have enough time for that debate after my presentation is over. If you have an urgent question that you want to ask, or if I'm using terminology that you don't understand, please do raise your hand and I'd be happy to answer. And on that note, I see a hand raised by Mr. Saeed Ahmed. You have a question?
No, sir, there's no issue. Actually, he cannot hear the audio. It's a problem at his end.
Okay, okay. All right, so I'll continue. So giving you just an overview of what PWRC is and how it operates. Our vision, generally speaking, is to promote and mobilize research and technologies that address water issues at a whole range of scales, from local community to national to provincial and all the way to global scale and international scales. The way we operate is by connecting and identifying various findings from natural sciences, from social sciences, humanities, and connecting them with local knowledge so that we can actually arrive at innovative technological solutions. By doing that, we hope to inform policy-making processes, and we also want to drive social change. And having all this evidence behind these policy and social changes actually makes for a longer-term impact. We also offer testbed for technology development, and we support development of various information tools that can help us identify what the emerging trends are around the various areas of research which are of interest to us. And we foster community engagement, community partnerships with practically everything we do, because at the end of the day, if the community where you're implementing your projects is not engaged with you, you cannot be successful in the long run. There are three broad research themes that we are focused on. We want to look at climate change, but we are specifically focused on the lens of adaptation. And our argument is that climate change is now a reality. It's going to take place, even if the best mitigation efforts are undertaken. Many parts of the world are still going to see extreme weather events. They relate to floods or droughts on both ends of the extreme. So we have to work with communities, work with countries to adapt to these changes. So that's kind of the entry point. We also want to look at water security in all its forms. And water security is not security, quote unquote, in terms of defense and armament, but we think of water security as the security of an individual, whether they have access to secure, safe, and sustainable water for all their uses. And thirdly, community engagement is a pretty major research theme. I will not go into individual research projects at the moment, but I'll give you a sense for the strategies that we use. So we are looking at creating partnerships for technology development with industries, with government, with various civil society partners. And I think there is obviously an opportunity to partner with NESPAC and other partners in Pakistan as well. We were very keen on creating an interface between science and policy, and we see this as a two-way bridge. And what I mean by a two-way bridge is that we look at the emerging policy challenges and we create research projects to answer those questions. And we also pick up existing research and translate it so that it can influence policy. So it basically goes both ways. We do have a significant international outreach. As I just mentioned, Ghulam Hussain from UET Lahore was an example of of that collaboration, which is still incidentally ongoing, just about concluding. And we also have a research collaboration with Agricultural University of Faisalabad, and we've also worked with New Tech, which is a new university of technology, which is a brand new university in Islamabad, which has just been established over the last 2 years. And our center is very keenly engaged in interfacing with students, with giving them opportunities for experiential research. And we also try to bring about leadership skills in amongst the students who are engaged with the center. So this is just a very brief overview of what kind of things we are doing, and just to give you a flavor for where we are coming from. Green infrastructure is one of the major research themes that my center has followed. And as you will see in a moment, it connects to the three strategic priorities of adaptation to climate change, to better water security and management, and to community engagement. Okay, so let's get into the main theme of today's presentation. So our focus is on urban stormwater runoff. And as you can imagine, this has been an increasing problem pretty much in every city in the world. I know 2 years ago, there was major flooding in Lahore. There's been major flooding events here in British Columbia and Vancouver. And I'll actually talk about a very recent event here. The reason for this increase in runoff are essentially twofold. So there's increase in urbanization, which is obviously tied to population growth. And with urbanization, there comes this replacement of permeable surfaces with impermeable surfaces, with essentially concrete and pavement. And that means the infiltration capacity is reduced. The second one is climate change. And we are getting in many parts of the world much more extreme rainfall events. And again, I'll show one to you in a minute. Here's a typical cartoon type description of what happens when you replace natural ground cover with something like 75 to 100% impervious cover, which is what you see in mostly dense urbanized areas. And what happens here is that in a natural ground cover, about half of the rainwater infiltrates. Some of it stays, about half of it stays at the shallow level, and the other half goes into much deeper infiltration into the groundwater. And the runoff is only about 10%. And again, because there is high level of vegetative cover, about 40% is evaporated or transpired through plants. And when you replace that, which is this panel on the right-hand side, the situation changes quite dramatically, and you're getting about 55% of the water is now flowing off as a runoff. And evapotranspiration is reduced, and also the infiltration is very significantly reduced. So from an engineering standpoint, those of you who are familiar with hydrographs, what that does is that if you look at the blue line here, which is under natural ground cover, you would typically have not a very sharp peak of runoff, and you also have a large base flow, meaning that the water runs off over a longer period of time. When you replace it with an impervious cover, which is this red dashed line, you see that the peak gets sharper, it arrives sooner, and also the volume under the curve is much higher as well. So you're getting more water faster coming through, and it runs through your systems quite fast. And as you can imagine, the urban storm drains or sewers, whether they're combined carrying sewage and stormwater, or in some places you get dedicated stormwater sewers, they have a limited capacity. And when you get these high and sharp peaks, as the red graph shows, you end up overflowing it or overflooding the system. Okay, so this is kind of a generic way of describing what happens when you are urbanizing an area. So what we are discussing is essentially taking this right-hand side panel and trying to go closer to the situation that was there before the impervious cover, like concrete surfaces and asphalt pavements were put in. Okay, so before I go into detail, I'm quite interested in showing you a very recent flooding event, which just actually happened last week here in British Columbia. It was an extreme rainfall event, and it's being called an atmospheric river because of the volume of water that it brought. If you look at the names of these cities in the short table, you see how much rainfall came down in about a 48-hour period. And we're going from from east to west. Hope is a city about, I think about 60 kilometers east of where I am. And it got over 250 millimeters of rain, in about the 48-hour period. And Pitt Meadows, the city at the bottom, is where I'm located. That also got 178 millimeters. Abbotsford, the second one bottom also got over 170 millimeters of rain. And you see that the damage is devastating again because the water drainage systems are not able to cope with this volume of water. So you see the urban areas flooded. A lot of people had to be evacuated, some by boats from their houses. A lot of the farms, as you see on this panel at the bottom right-hand side, were flooded, and a lot of animals had to be rescued, and a lot of animals actually died as a result of the flooding as well. What is most interesting is that there were also quite a few mudslides and landslides, and there were also fairly significant infrastructure damage. So this panel that you see on the top right-hand side is the Coquihalla Highway, which connects the western part of Canada to the eastern part. So it's causing some major disruptions because of the damage to this highway. And as you can imagine, because of the bridges breaking down, it's going to take a while to rebuild this highway system. So the state of emergency was declared here in British Columbia at the end of last week, and the Canadian Armed Forces are helping the local communities in coping with this disaster. So I think a lot of this probably sounds very similar because we have encountered similar flooding events in Pakistan over the last 10 years. The next image I'll show you, oops, sorry, going in the wrong direction. This is, again, the Trans-Canada Highway running vertically in this image. So here it is in June of this year, and here it is last Friday. And you can see parts of it, parts of the highway are submerged. The approaches to the highway are submerged. So again, it is a major disruption because a lot of the goods are transported from Vancouver, which is one of the busiest ports in Canada, to the rest of the country going eastwards. So this is a bit of a tangent from the main theme of my presentation, but I thought because this was literally happening as we speak, I thought I would show this to underline that no country, no city is immune to the magnitude of extreme climate events that we are facing as a result of climate change. Okay, so let me pause here and ask you guys a question. And please feel free to respond in English or Urdu, whichever you're more comfortable with. What do you think are the most significant impacts of the change of land use on water? What kind of changes would you expect? So anyone, let me allow you to unmute, and if you have a response, or type it in the chat box, either which way. Okay, that's a great point, Muazzam. Yes, you're encroaching onto natural drainage routes, a lot of times you can't even tell where the original drains or streams and rivers were, and that happens in many densely urbanized areas. Okay, other things. Okay, yeah, drainage is a significant problem. So Nabil, actually, the runoff is significantly increased because of urban land use, not decreased.
The green areas are reducing and water seepage reduces.
Exactly. Yes. Thank you. Yes, groundwater is also impacted, but in more than one ways, and I'll describe that in a minute. Okay, Tayyibah, you had a very good point. Because of paving, there's a greater runoff. Okay, I don't know who is with this number, but that's an excellent point also, that it's typically drains and sewers are not planned for the kind of runoff that we are seeing or what we might see in future. So to give you an example, the city of Vancouver, which is pretty densely populated and very urbanized and advanced, the drain system is designed for 48 millimeters of rain in a 24-hour period. So I was just showing you rainfalls, which was over 170 millimeters over a 48-hour period. So we certainly were seeing that capacity exceeded as well. Okay, thank you very much for your responses and for sharing your thoughts. So let me talk about what kind of impact. So the first one is, as some of you were pointing out, there's an increased runoff quantity. And what that does is that it causes traffic disruptions because sometimes the shallow parts of streets and highways get flooded. There's an economic loss because of disruptions which are caused. And there's also public health issues because many times you see that the flooding can get into sewers, and the sewage actually comes out and mixes with stormwater. So a number of problems with the increased runoff quantity. There are also impacts on the aquatic environment, and I think someone was already starting to point this out. Because of the increased velocity, there is a greater level of erosion. There's stream bed scouring, habitat degradation for various kinds of wildlife as well as aquatic life. Different fish species are impacted. And there's, of course, increased sediment transport and sedimentation. And I just saw a very interesting satellite image that after this flooding here in British Columbia, we could see a huge plug of sediment going into the Pacific Ocean at the outlet of Fraser River, which actually runs pretty close to where I live. So the sediment transportation and sedimentation is also much higher than what you would normally have. There's also impacts on water quality as a result of that. So you would have more solids going in, you have more organic matter being flushed out, and there's other toxic materials coming in as well. So you would expect heavy metals, synthetic organics, petroleum hydrocarbons, and all of these have an impact on the aquatic ecosystem. They can reduce the dissolved oxygen which is available. They can also have carcinogenic impact on fish life, where they can cause long-term health impacts and cancers. And they can also impact spawning areas of various fish, which are particularly important here in British Columbia, but that's true of any aquatic system. pH and temperature variation changes distribution of species as well. So there's fairly significant impacts on various aquatic ecosystems. So these are the problems that we have to cope with. And this is where we come in with what we call nature-based solutions or green infrastructure. And in different contexts, green infrastructure means something slightly different, but here's how we are defining it. So these are essentially water management approaches that protect, or they restore, or sometimes they mimic the natural processes. And in these approaches, we use plants, we use soil systems, we use permeable materials. So you can have things that look like engineering systems, like these permeable pavements that you can't tell on the surface that it's a green infrastructure, or you can put green roofs on top of buildings, which you obviously can't see from a distance, or you can go with these swales or trenches, which on the surface looks like normal vegetation, but there is a fairly significant engineering design involved. And I'll describe each one of these in more detail in a few moments. Okay. I think it's important to point out that there's lots of different language being used in publications and research. For example, in China, these approaches are called sponge city approaches. They're also called sustainable urban drainage system, or SUDS, or low impact development, or LED. And they're also called water sensitive urban design. So depending on context and which country you're in, you might find one of these terminologies: nature-based solutions, green infrastructure, sponge city, etc. Why are we interested in this? There are some fairly significant benefits and also some challenges. So the benefits are that we, as a side benefit, we provide more green space, are important for health and well-being of population, for communities living around these structures. They indirectly provide opportunities for citizen engagement. You can bring people in and they can become a part of the construction process or planning process. And you basically raise their awareness about what the issues are, and that leads to better outcomes. And again, I'll give you some local examples from what we've done here in Vancouver and through my research center. You can lower the greenhouse gas emissions. So the carbon footprint, as we call it, is lower for these kind of approaches. So, and part of the reason is that when you're using cement, for example, or concrete, just production of cement and concrete is fairly intensive in terms of greenhouse gas emissions, and then you're trucking it in, and you're using some fairly intensive labor for putting those in. So by foregoing all of that, you lower your greenhouse gas emissions. There's also greater flexibility to adapt to future challenges. By changing the permeability of these systems, you can say, okay, now we are seeing much more intense rainfall events and more intense floods. So we can change these systems quite easily as compared to concrete or asphalt pavements. You can't really change them very easily. They also reduce the stress by reducing the volume of water that's going into the so-called gray infrastructure, the steel and concrete pipes that convey water away from urban areas. You lower the maintenance cost, and there's also a much better removal of the pollutants of the kind that I was just talking about. Particularly organics and heavy metals are much better retained in these systems. But implementation of these are not without their own challenges. So there are some knowledge gaps about how well these systems will be performed in the long term. So here in Vancouver, for example, these systems have just been used in the last 4 or 5 years. So the engineers like myself are concerned about what will be the long-term performance. Is it going to be very expensive to maintain them 15, 20, 25 years from now, etc.? There's also insufficient allocation of funds, which means that the scale at which these are implemented are relatively small. So it's kind of hard to know how effective they will be in reducing the flow of stormwater runoff if you're not executing them at a large enough scale. So it's a bit of a chicken and egg story. You need very good evidence to demonstrate that these systems perform very, very well. But then on the other side, you need to invest in these systems to get that evidence. And without the evidence, the funds will not come. Anyway, we are stepwise moving in that direction. And some of the European countries are much more advanced than we are here in Canada. And the other challenge is the lack of enabling policies. And those policies include engineering design standards, for example. And there's also not very good information available about what is the performance expected of these systems either. So this is where my center is now focused on looking at both engineering standards and identifying the performance standards of what you should expect from removal of pollutants and what you should expect from infiltration of rainwater into the groundwater. And lastly, there's lack of adequately trained personnel, and that means most of the engineers who are in the system, both in municipal governments and in the private sector, they've not really been trained in the design, and these are like very alien structures to them. So there has been an effort made on part of the cities around us to basically bring together resources so that people are more familiar with these applications, and there are training opportunities for for having a cadre of engineers who is well trained and well equipped. So if I think of the application of these systems in Pakistan for a moment, you would see pretty much all of the same benefits and all of the same the challenges in Pakistan as well. I'm sure there's concerns about performance. Funds are never there for these types of systems, which are brand new, and you can forget about design standards, etc. And so I think there is an opportunity for us to work together, and I would make this as an offer to think about how we can actually work together moving forward. So let me now dig a little bit deeper into the different categories of these green infrastructure applications. So the first one is called bioretention cells or bioinfiltration cells. And these are essentially permeable units which have plantation on the top, but they underneath have, on top of existing soil, there's a gravel bed, and there's also specialized bioretention soil. You also would want to put some geotextiles on the sides so that the water is actually channeled into the gravel and towards your outflow. And that outflow could be either infiltration down into the towards the aquifer into your groundwater, or it could be an outflow towards the towards your stormwater system. And there are some general specifications about the slope that is typically designed. You can also have some stone weirs that bring water in, and you can see here at the bottom there's an example of that. So these systems can be put on the roadside, or they can be in in open areas and parks. They can be built around public buildings, etc. A special type of it, and I'll give you an example when I talk about what my center is doing, is rain gardens. And the additional element in rain gardens is that instead of the outflow, you can actually have a water storage unit at the bottom of these systems that allows us to store the water and use it in summertime or when your rainfall is low. Quite interesting systems, and they are seeing greater application in this part of the world. Infiltration trenches are also fairly well-defined engineered systems, And basically, as the name says, these are trenches with gravel or permeable material, and you have a drain that is running downstream that brings water down. And when you're done with these on surface, there's not much to see. But again, you have a system underground which can either carry the water to a storm drain, or it can actually infiltrate, which is obviously the more preferable option, is to infiltrate the water towards the groundwater. Another similar application is vegetative swales or bioswales, as they're called. And in this case, they are similar to infiltration trenches, with some differences, that they are getting inputs from both sides. There's a there are some design considerations about what is the slope that you want. But the interesting bit is that you can actually have plantation. And here's an example in a mall, in the parking lot of a mall, where all the flow from the parking lot is draining towards this bioswale. Or you can also have, here's a major street, and the runoff can be directed into the bioswale through your typical, you would, in a normal engineering design, you would have these connect directly into the sewer system, whereas you can actually have the rainwater drain into the bioswale. Okay, now there's a few other systems which look less natural on top, and permeable pavements is another one of these kinds, where if you look at the surface on the top, they look like your ordinary concrete type pavement, but actually the in between the pavers, you have permeable material in the joints. And then underneath are these different graded layers, and at the bottom you might have a geotextile or compacted subgrade soil. So it starts to look a bit more like your regular highway design or pavement design, with the major difference is that this layer is essentially connected to a drain which drains the water away from the highway. So instead of having a drainage system on the margins of the street, you have drainage going vertically down into the subsurface. Okay. Rooftop gardens or green roofs is another application which is gaining a lot of attraction because it has a number of benefits. The obvious one is that it creates an attractive space on rooftops, which can be put to different kinds of uses. But it also can be designed and engineered in a way to reduce significantly the runoff. You can actually grow vegetables on top. And again, there's quite a bit of, sorry, skip forward. There's quite a few engineered materials that are being designed and sold. There are these drainage boards. There's also roofing membrane. So you actually want the roof to retain the water, but you don't want obviously it seeping through the roof. So you would want to have some kind of a membrane to make sure that it's securing your roof structures beneath it. Now, the other footnote in these roof gardens to keep in mind is for those of you who are inclined towards structural engineering, is that obviously you want to make sure that the additional load that you're introducing, your roof structure is designed to carry that extra load. Okay, so maybe I'm stating the obvious, but I think that's an important element. And then I think this is something which is probably discussed more in Pakistan and a number of other countries, is rainwater harvesting into rain barrels or tanks or what have you. And basically what you need is an impermeable rooftop, and then you can have these systems connected to your drain system from the roof so that the water is collected. And in some countries, I know the collected water is used for drinking purposes. But I know from experience that there are a lot of water quality problems in this water, and you probably don't want to drink it, but it's very good for irrigation. And you can, if you really have to drink it, then there has to be some kind of a primary or secondary treatment done before it gets to drinkable quality. Okay. And then what we've seen here, this is a picture from Vancouver. Another type of green infrastructure is constructed wetlands. So this is where water is routed through these grassy systems on an ongoing basis, and you can use these wetlands to store excess rainwater, for example. But you can actually, in some cases, also use these as secondary or tertiary wastewater treatment systems as well. So we know that these plants are typically quite good at fairly significant removal of pollutants. Okay, and then there's some integrated solutions. I'll skip this image and maybe go to this one, which is a little bit more clear. There are examples. We have a lot of trams here in Vancouver. So there are what we call blue-green applications where the tramway can also have planted materials, and then you can have, for example, biospheres underneath. You can integrate rain gardens in your median strips. You can also have biospheres next to the parking areas, etc. Okay, so all of these different types of solutions can also be brought together if there is the opportunity. I think conceptually it's important to understand how the historic development has been for urbanized areas and how these green infrastructure solutions fit in that larger equation. So in earliest history, and you can go back to the Roman Empire, they were water supply cities. So water was brought in and it was supplied to various households or different users. And from that point onwards, it almost took us another almost 1,500 years or so to get to a point where we had sewered cities, and the next step was drain cities, where because of highly impermeable surfaces, you needed to drain the cities as well. The next level up are waterways city, where waterways and the examples you can think of is Venice, where the waterways are integrated into the city itself. The next stage, and this is kind of where we are now, are water cycle city, where you can actually incorporate the entire water cycle, which means the water is deliberately reused when it goes through these green infrastructure systems. And water sensitive city is the pinnacle of design, if you will, of urban systems, where we hope that we can look at a system that can sustain for decades and serve a number of generations. So that's kind of where we are going conceptually, and that's where the this whole notion of green infrastructure fits in very, very well with this. I'm sorry, my slides are jumping around a little bit. It fits in very well with this notion of water cycle city, and it would fit with the notion of water sensitive city. Okay, so I think there are some innovations that come as a result of these types of urban designs. The obvious one is that there is a greater emphasis on walker-friendly spaces, having more green space where people can walk or enjoy nature. That means the green space and infrastructure is serving now multiple purposes. So it not only is providing better drainage for extreme storm systems, but it also is serving a social purpose. And it helps in improving health through physical activity, through recreation. And I think many of us encountered that, particularly last year when, because of COVID-19, everything was closed up. So the most you could do was to walk up to these green spaces. So I think there has been a new recognition for the value of these type of systems. As I said, there's better stormwater system, there's enhanced ecosystem management as a result of these green infrastructure solutions. There's also a reduction of water consumption. And what is interesting is by making people more aware of water around us, it actually helps people reduce their water consumption. There's also increased water sustainability, particularly if in a rain garden, if you're storing your excess rainwater below the garden, or if you have a rooftop garden where you're using that rainwater to putting it to productive use to produce vegetables, for example. So there are some benefits in terms of water consumption. It quite naturally leads to urban farming, and there is an increased focus on locally grown produce, and we've recently, because of these flooding events last week, we've realized that a lot of the food which is coming in from outside the city can be quite seriously disrupted if a highway washes away. And by doing that, you're actually also reducing the carbon footprint because your food is traveling a shorter distance to get from where it's grown to your table or to your plate. And there are other indirect economic benefits. You're creating a lot of local jobs. And typically where these structures go in, there is also an increase in property values. Okay, I'll go through this last part a little bit more quickly. I'm quite cognizant of how much time we've taken so far. So here are some examples of green infrastructure projects. So in Vancouver, there was a Greenest City Action Plan that was decided about 10 years ago, and the ambition was that Vancouver will become the greenest city in the world by 2020, which was last year. And we've, I think, come close to it, but not quite. And obviously, COVID disrupted quite a few of the ongoing projects and activities. But there has been a lot of emphasis on more bike lanes, more urban gardening, better recycling, etc. There's, as I was showing an image of constructed wetlands are there. There's a lot more green roofs in Vancouver. And there is an increasing number of rain gardens being put in on roadsides in particular, and many of the parks are also putting in rain gardens. And the ambition is to increase this number to several thousand rain gardens in the Vancouver area. So that's what we're hoping to do. And there's quite a lot more permeable pavements as well. Here's an example of a rain garden that my center helped put in the Horseshoe Bay area, which is an area northwest of where I am. And this was a small plot in a park within a community where this rain garden was put in. And the interesting bit is that while the funding was raised through my center to provide some of the materials and bringing in the plants, all the labor was done by the local people. It's the community itself that came together. And if you see on this bottom right-hand side, it's Dr. Joanna Ashworth, who's my colleague, who has been leading this Rain Gardens project. So she brought together the community members to do all the work. And as I was saying, by doing that, there's a much higher level of awareness within the community. We also had a second project in a mall where the mall owners were quite nice to donate some parking spaces to us, and we removed the pavement and put in the rain garden. And again, the community members were engaged, even children were taking active part in this whole process. And Quite interestingly, we are also monitoring the benefit of these rain gardens. We're looking at water quality, which comes off from these, so that we can actually demonstrate the long-term efficacy of these systems. Okay, so let me conclude by talking about some evaluations on how well these systems work. And this is work that was done by Dr. Ghulam Hassan of UAT, who was working here with me. And if we look at the pollutant reduction by these green infrastructure applications, the runoff reduction, as you can imagine, is the best performance is from vegetated swales or infiltration trenches, or even with bioretention. And again, if you look at the maxima, even rain barrels can be quite effective if they are implemented correctly. Green roofs are a mixed bag. There can be some relatively high performing roof gardens, but typically they're only reducing on average the volume by about half. Similarly, we can look at the effectiveness of various systems in terms of the reduction of various pollutants. And on the top, again, there's runoff, there's total suspended solids, nitrogen, phosphorus, zinc, some of the heavy metals, zinc, copper, lead, and total petroleum hydrocarbons. So again, by and far, the bioretention cells and infiltration trenches perform the best. And green shows better performing, red means negative performance, yellow is kind of low performance, and the number of pluses shows you how well something performs. And I'll share this slide with colleagues at NESPOC, so you don't need to worry about taking notes, and you can look at these at your leisure. So some of the issues and challenges, let me summarize. So there are some skewed perceptions and some knowledge gaps about what these structures are and how they work. The understanding of how they improve water management, both for quality and quantity, that's not well understood by engineers most of the time, and it's certainly not well understood by the general public. And many of the people who are making decisions, they perceive these quote unquote non-conventional solutions as risky. And so, they tend to shy away from these type of solutions. And obviously there's some uncertainty about long-term operation and maintenance costs. So that's something that I said at the outset, that because these systems are relatively new, even we don't have data for how they will perform over 25 years or 30 years or a longer period of time. There are some institutional challenges. Regulatory standards are not present, so we don't have regulations for design, for performance, and that means it's not very clear what type of materials would work, what should be the engineering designs, and what should be expected in terms of performance. Okay, and there are some policy gaps. The incentivizing to implement. So particularly for some of the larger builders here in Canada, you need to give them some incentive to use these type of solutions as opposed to your traditional concrete and steel solutions. And similarly, you can think about in Pakistan how you can incentivize some of the very large urban projects that have come up, and whether those builders can be convinced to incorporate some of these solutions. There's also a question of jurisdiction sometimes in terms of who is responsible for taking care of what. And it can be complicated. In Vancouver area, for example, there are 12 or 13 municipal governments. Groundwater flow intersects all of these municipalities. So it's sometimes jurisdictional issues become complicated or difficult. And finally, you need political leadership, people who are really interested and are keen to implement these innovative concepts. And finally, there's a challenge about confidence. So there's obviously lack of prior experience, and that lack of experience is both in the software, meaning people who know how this works, and in hardware, on what gaps in human capacity, and there's an absence of data. So these are some of the issues which are recognizable, and all of these can be addressed in one way or the other. So let me leave you with some our conversation. So are green infrastructure options really accessible to all cities? Sorry, was my connection disrupted for a moment? Okay, well, anyway, I'll repeat myself. So these questions are meant to facilitate some of the discussion. Are green infrastructure solutions really accessible to all cities? Can you apply them everywhere? Could we have more stringent policies that will help overcome these challenges that I was just outlining? How does the COVID-19 pandemic fit into this? Because a lot of the government's attention has now shifted from environmental problems to health problems. So what role does that play? Is there an opportunity? Can you make some arguments that these solutions are important from a health perspective? What is the role of various stakeholders? And by stakeholders, I mean government, I mean public, I mean construction sector, builders. There could be suppliers, for building materials, and there could be different community organizations. So all of those are stakeholders. How do they engage, and what is their role in their design and implementation? And there are some general questions also to keep in mind. How much of the urban area should be set aside for these type of green infrastructure solutions? Should it be 1%, 0.5%? Should it be 15 or 20%? So these are all questions that we can pose, and hopefully we can discuss. So let me stop here. I know we are slightly shy of an hour mark for the presentation. Let me stop here and pass the floor back to the moderator. I'll stop sharing my slides for the time being and see if there are any questions.
So no questions right now, but let's wait a few minutes.
Okay, so there was one earlier question by Adeel that said that these systems are workable and more reliable for humid regions. For arid and semi-arid regions, precipitation is low in frequency and high in intensity, and there may be a high financial impact. So there's actually a number of excellent points flagged by Nabil in this question or this comment. Let me tackle them each one by one. So you're quite right that the frequency is low, meaning that there's a shorter rainfall period where there's a high intensity of rainfall coming through in a very short period of time. And I would argue that that actually is a reason for implementing these designs, because they allow you to store water and stretch out your rainwater over a longer period of time. They also help, and I know there was fairly major flooding 2 years ago in Lahore. Part of Mall Road had collapsed, so, and the reason was that your engineered systems were overwhelmed. There was too much water for them to handle. So you actually want to have these systems be in place so that your runoff is reduced. And so you want to actually be able to cope with those high intensity but low frequency precipitation events. You also raised the question about high financial impact. And my argument is that it's actually the opposite. that these systems are much cheaper than concrete and steel type traditional engineered structures. And particularly for Pakistan for two reasons. One is that labor is significantly cheaper in developing countries. And these, as you could see from the slides I was showing you for community engagement, these are relatively labor intensive tasks. So Pakistan has cheap labor. You can create actually a lot of jobs. And because the materials are also cheaper compared to concrete, it actually is a much cheaper option than your traditional systems. And actually, there are now more examples coming through in drier areas, and particularly you have to think about putting in drought-resistant plants so that in the dry periods, these plants can sustain themselves. So each one of those issues that you flagged, and they are quite important, there is a workaround or there is a solution for that problem or that challenge. So I hope I've answered that. If you have a follow-up question, I'd be happy to expand more. Okay, so thanks for the question, Omar, about implementing in developing countries like Pakistan and in other parts of the world. So there's you're right. There's lack of policy and perhaps lack of political will, and I would add to that there's also lack of awareness of both the benefits and also the challenges these systems would bring. I'm not sure that there is actual lack of space because I think, and again, I'm from Lahore, so I keep thinking of the various areas in Lahore, and there's actually quite a lot of spaces where these type of solutions can be piloted. They can be shown to work successfully, and they can be quite successful. The question is, what will be the trigger? How can we get started? And I think what it takes is actually a handful of people or institutions which are interested in implementing these solutions. And once you have these, the first raindrop is there, others will follow. And I think there are examples in many countries in Asia where these type of solutions have been implemented fairly successfully. And I'm thinking particularly of Thailand, where these solutions have been implemented in some dense urban settings. Okay, next question from Alisher. Our cities are traditionally developed and not properly planned. I would actually tend to slightly disagree with that because even if you look at the core of the cities here in Canada or in Europe, where I've spent a significant amount of time, they are also very densely populated and are not designed for today's challenges. And I actually showed you images of Abbotsford, which is about 10 kilometers away from where I am as the crow flies, and it's a fairly well-planned city. And that city was the first one to declare an official state of emergency after the floods last week. So the lack of planning, I guess, is not an argument for not improving things. In other words, if we know that some of the storm sewer systems are not capable of carrying the load, that actually is an argument for putting in these systems to take some of the load off, because it is in fact very expensive to dig up and put in larger sewer pipes, and it's obviously very, very disruptive to traffic, and it's very disruptive to people who are living around those kind of improvements. So I hope I kind of answer those questions. So even if the cities are not properly planned, you can still impose these solutions in there. Okay, so a follow-up question about urban forest. So that urban forest is actually in Clifton in Karachi, not in Lahore. And there's a colleague, a very interesting community leader by the name of Masood Lohar, who's leading those type of applications, and he's working in Karachi to build many of these green infrastructure solutions and providing people with plants so that they can lead some of these solutions, locally there. Okay, so Ali Sher had also a follow-up question about case study for such cities. I would say if you want to really look at the gold standard, the top class solutions, I would say go to the Netherlands, and Amsterdam is a city which has implemented the most number of these solutions. It is really, in many ways, I think the pinnacle of water management approaches and engineering design of these systems. So I would say look that up and see what they've done. Okay, so Imran Ahmed Khan Saab had a question about a necessity for separate designs for stormwater and sewers. And again, I think the arguments are kind of obvious. So one relates to the quantity and flow or volume of water that is transported. Stormwater typically carry a much larger volume, but you don't need to treat that water, so you can take that stream separately. Whereas the sewers or the sewage system is carrying water which is very polluted, so you don't want to mix it with storm, and the volume of water in sewers is significantly lower compared to the volume that is carried through stormwater systems. So there is that logic, but obviously it's more expensive to put in these two separate systems. And also, as we were discussing earlier, if the city is not planned from the beginning to carry these type of dual systems, then it's very hard to go in, rip up what's there, and put in a dual system. So if those systems were not designed to begin with, then you are in trouble. Irfanullah Khan Saab talks about effective, economical, and helping with community safety and quality of life. No disagreement there. Thank you for those comments. Nabil Saab had a follow-up question about Karachi is, I think it's more like a semi-arid city. High intensity rainfall. Yes, so the question is whether it's not better to increase the drainage capacity. Yes, you most likely will need to do that as well. But as you design, and as we know from engineering standpoint, we are always designing for, say, a 50-year rainfall event or a 100-year rainfall event, except that our hydrographs are no good anymore. So what we used to call a 100-year flood now can happen once every 10 years. A 50-year flood can happen every 3 years. So there's a problem, and this level of lack of predictability to some extent in terms of what should we expect. And I can tell you, even here in Vancouver, as I said, the design standard is 48 millimeters of rain in a 24-hour period. And we know just from last week that that's not enough. But the engineering community has not quite caught up with that change yet. So I come back full circle to my argument. yes, you need to increase the drainage capacity in a city like Karachi, but you need to provide a reduction in that need for drainage in the first place by putting in these green infrastructures that can help uh, infiltrate the water down into the groundwater. And that for a city like Karachi, there's a secondary benefit because you are concerned about saltwater intrusion into the aquifer, and by putting in more infiltration, you actually are indirectly countering the that runoff as well. Okay, Anas had a good point about launching these projects in densely populated areas as pilots. And I think that's where you will see the, as we say, the biggest bang for the buck, how much benefit you draw from these systems. And yes, Imran, we would need to manage these systems effectively and maintain them for them to operate. And that's why particularly when you're at the early stage of implementing these solutions, you need to have a fairly significant data collection system in place. So you know how your system is performing so that you can make sure that if its performance goes down, for example, if the infiltration amount is going down because your silt is choking up some of your engineered layers, then you need to do something to reduce the amount of silt infiltrating through, for example. So you need to have data available, to be able to maintain these systems in the long run. Okay, next question is from Wasim. Says, whole life cost, asset management, code, provision of maintenance. Yeah, excellent points, Wasim. All of these are very excellent points. You do want to have a life cycle assessment, and that means you can compare apples to apples, as we say. So if you look at the overall life cycle cost of a green infrastructure and you compare it with the life cycle cost of, say, putting in a much larger diameter stormwater drain, how do they compare to each other? And yes, we are, as I said, in the process of building various standards and codes for both design and for maintenance. So from a purely engineering standpoint, I think we are in early stages of development, and I think the playing field is quite even. So it's not that developed countries are much more advanced than developing countries, again, with the exception of maybe the Netherlands, which is certainly more advanced. So in this level playing field, we can actually help each other move forward. And once you have all of that information and data, then that will lead to commitment for provisioning of maintenance, for budget allocations, for resource provisioning, etc. And all of those are very, very valid points. Okay. And if I'm not directly or completely answering your question, please feel free to follow up and post another question or ask for more clarification. Okay, so the next question is from Tayyiba, who asks, they should be included in local building codes, and environmental impact assessment procedures should be included in Pakistan and in new development projects. Right, so you're absolutely correct that you need to have these policies focus more on new developments. I think that's where it's easiest. And this time, actually, I was in Pakistan just 2 weeks ago. And as you travel around Pakistan, you see lots of new urban development coming up basically everywhere. There are these housing societies and urban development schemes coming up in practically every part of the country. And as these options are, as these developments are coming out, that's the right time to go in with a policy and say, you should already plan to implement some of these systems, and by incorporating them within building codes. And I have no illusions or delusions that this can happen overnight. It will take several years to get to that point. I know my student, I mentioned Andrea McDonald at the beginning of my presentation. She did a comparison here in Canada between federal regulations, provincial regulations, and municipal standards, and she found that there was lots of disparities in those standards between going from national level all the way down to the local level. So again, there's no significant advantage that I can say that developed countries have over developing countries. I think there's a fairly level playing field, and there's nothing that's stopping folks in Pakistan from leapfrogging and going from where things are now to actually a much more advanced systems implementation. Okay, other questions or comments? Okay, so there's a question from Aslam Saab about, in a city like Lahore, it's hard to rebuild or get places of land to implement these ideas. Well, let me offer some suggestions. There's lots of space around Qaddafi Stadium. There's space on Mall Road all the way from the City Hall down to the Miami Bridge. There is this green space in the middle where these solutions can be implemented. There's green shoulders on both sides. There's lots of parks in Lahore where you can implement rain gardens where water is stored locally and it's used for watering the plants in the dry season. So I don't quite agree with the notion that it's hard to find space. Actually, there's lots of space in Lahore, and I'm a Lahori myself, so I know there's lots of spaces where this can be implemented. Any park, any median strip, which is a green median strip, can be retooled to have this type of applications be placed. Yes, in Old City, you're right. It might be more challenging. If you go inside the walled city, it might be more difficult, although there are still areas, outside of Badshahi Mosque and next to the Minar-e-Pakistan, there's lots of green space there. There's lots of space next to where the food street is, which is also a small park where the solutions can be implemented. So not inside the walled city, but right around the walled city, there's still lots of space. Okay, another question from Ali Sher. Treated wastewater can be used for irrigation purposes. Yes, that's a great suggestion and idea that with some primary treatment to wastewater, it can be used for irrigation. And I think it's a slightly more complicated an issue because you have to be then concerned about safety of these systems, because if you're saying people can come and enjoy these surroundings, then you want it to be also safe from a health standpoint. But anyway, with some wastewater reuse after some primary or secondary treatment, you can actually use treated wastewater for these green infrastructure solutions. Yes, Omar. I'm quite aware of what's happened to the Walton area, particularly around the club, what is it called, the Air Club or the airport that used to be in Walton, which is now being converted into, um, into a developed area. And the only thing I can say is that it can be an opportunity if there were the right kind of leadership demonstrated. So maybe I can put the ball in the court of NESPAC. Maybe you have access to your own facilities or your own offices somewhere in Pakistan where you can start implementing these solutions and show them to your potential clients. I would be very happy to collaborate with you guys to implement these solutions. Okay, so there was a follow-up question by Imran about, I take it you're talking about water for drinking purposes or other utility purposes. So yes, it's possible to actually treat water, wastewater to enough quality that it becomes drinkable. The best example I can think of is Singapore, where about a quarter of their water supply is treated wastewater. So because Singapore, as you know, is a very small island and they have to buy their water from Malaysia, and they are reducing the economic burden, drinkable quality, and then remixing it back with the fresh water they buy from Malaysia. And they call it new water is the term they use. And they've had their ministers go into the wastewater treatment plant, fill up a glass of treated wastewater and drink it. So there's been a very strong push in Singapore for actually using it for drinking water, drinking purposes as well. As for other utilities and irrigation purposes, there's quite a lot of examples around the world for using wastewater treated and sometimes even untreated wastewater is used, although obviously it cannot be recommended because it's not safe. So lots of opportunities for treating wastewater, although that whole topic is slightly distant from our focus of discussion for green infrastructure. Okay. So there's another comment about densely populated areas and these ideas being implemented into housing societies and spaces being newly planned. Absolutely agree with that. I think there's lots of opportunity. So if you can convince maybe some of the larger developers like Barrier Town or DHA folks to say this is something they should be doing in terms of scale, I think they're biggest developers compared to anyone else in Pakistan. But you're right in making that comment that we need to spread awareness, and the need or the benefits need to be made available to everyone. So in response to Aslam Qazi Saab's question, do we have a design manual? Interesting that you asked that question. My student Nick, who's actually working part-time at the City of Vancouver, is actually working on developing a design manual, and he has developed some initial CAD designs which I think are eventually going to be publicly available. So these give you design specifications for exactly how you should design, what should be the spacing from the road, for example, what is the depth of various layers, what should be the grading, what type of materials go in and which layer, et cetera, et cetera. So that those design manuals, I would expect maybe by the end of next year, I'm hoping that they will be more publicly available. Nabil, very interesting question about areas with high groundwater level or areas where we see water logging. These type of solutions will most likely not work where your groundwater level is very high. Because what you're trying to do is get the water infiltrated into the groundwater, and if your groundwater level is already high, then infiltration can't take place, or worse, you might have your water logging, coming up, and salinity coming up into these green infrastructure solutions and destroying the plants that you have put in there. So that's a different problem, and it has a different solution. So these aren't really the kind of solutions that you would normally think about applying in waterlogged areas. Okay, any other questions or comments or suggestions, ideas? Again, I have an open offer. My contact information is available on my center's website. You can write me an email if you're really keen to implement these solutions on a pilot scale. I'd do my best to help you and provide you details, standards, manuals, etc., whatever is needed. Okay, so I can maybe pass the floor back to our organizers and see if you want to conclude the session.
Let me ask Umar Saab for the concluding remarks. Sir, Umar Saab, if you'd like to make any concluding remarks, sir.
Conclude तो अब क्या करना है Zafar, thank you very much Dr. Zafar. We've had a remarkable आपकी presentation, ज़बरदस्त थी, and your ideas are absolutely out of the box. But as मेरे questions भी थे, लोगों ने भी questions किए, it's more about implementing and awareness. I mean, that's what what really is. Something this is new, or what struck me, or आप लोगों ने, I'm not sure if I'm sounding correct or not. Can you hear me properly?
Yes, sir.
Okay. So what struck me was that your city had already decided in 2010 that you need to do that, switch over to the greenest city or whatever, and we haven't yet started that first step also. So and considering the climate change, it's going to be difficult. I mean, we'll have as you're aware that Lahore is now the most polluted city. We've been there for the last 2 weeks now, and aaj subah ki thi khabar, ya probably yesterday's, that the average life expectancy for locals of Lahore or Pakistan has been reduced by like about 9 months. I'm not sure how they came up with the statistics, but obviously these things are having a great effect on it. And we appreciate your research and everything that you're doing for us and for your own country and for this world in large. So thank you very much, Dr. Adeel, and I'm sure the coordinator would like to probably say for sure thank you. I'm sorry, I had my things off because I had a guest somewhere. So thank you very much, Dr. Adeel, and it was a pleasure having you, and we'll have you once more after a gap of about 4 or 5 months, and let's see, so you'll have other things to talk about with us.
Thank you. Thank you for those kind comments.
Thank you so much, sir. Thank you for sharing your knowledge, your research. It was a very interesting topic, very enlightening. It's always a pleasure to have you with us. Thank you for your time. Thank you for precious time. And in the end, I would like to thank all the participants too. And that will be all from my side, sir.
Thank you very much. Allah Hafiz, everyone.